Okay, so we're gonna, part of this unit is actually assuming that you all remember linear equations from grade 10. And I realized that it's often not necessarily the case because you took Intro to Applied and Pre-Cal different times of the year. So we're going to do a little bit of a review before we dive into inequalities, because we're going to have, ultimately, we're going to deal with inequalities. So if you go to page 3, I'm going to use a red pen here from time to time, and of course highlighters as always. This is one of the units we're having some, like a ruler or a straight edge or something is going to be very helpful, okay, because we're going to actually graph lines a lot. So here we go. So what's the slope? You remember the word slope? I think so. It indicates the steepness and the direction of the line, so whether it goes up or down. So it tells us how sharp is the incline and also which way is it pointing. Is it pointing up or down? And here's the formula. Slope is rise over run, which is also known as the vertical change over the horizontal change, which is also known as y2 minus y1, x2 minus x1. I think if you see this, you probably have some flashbacks, maybe good ones or bad ones. But don't worry so much about it. I'll walk you through it. I'll show you some examples. It's one of my favorite units in Intro to Applied and Pre-Cal, but you might not think so. So we have four major types of slopes, and the first one is positive. So it doesn't matter where you draw your line. Always read your line from left to right. Okay, so if you're like, is this going up or down? Just read it from left to right. If it's going up that way, it is a positive slope, right? So we're just gonna have the line would look something like that. And notice, I'll just make a note here, it's a diagonal line. And this means, diagonal line, right? This means that there will be x and y variables in the equation. Diagonal line, x and y variables. This is a short version of variables, okay? Rises from left to right. You know it's a positive slope, and you know it's a diagonal because there would be x and y variables. The classic equation, or one of the ways to represent this is y equals mx plus b. I feel like that will also give you a bit of a refresher, right? The slope times x plus b. B ends up being the y-intercept. We're going to look at it more later on. You could also have a negative slope. The equation will still look the same. It will still be y equals mx plus b, but in this case, our ruler, if you go from left to right, it's going to go down. It could be sharp, it could be shallower, but this is the case, right? Diagonal, that means both variables, x and y variables still. And this one drops from left to right. Drops from left to right. Let me just raise this a bit. So these are the two main cases, but then you have I call them special cases. You have your undefined slope. Which way does your line go when your slope is undefined? Up and down? Yes, sir. Vertical line. And so a vertical line is obviously, goes up and down. So it doesn't matter where. I'm just going to make a line going this way. That's why I use red. Okay. And the reason why it's undefined is this. Your rise, it doesn't matter which 2 points you would pick, there would be a number for your rise, correct? You would come up with it. But is there any run? You're not running. And a number divided by 0 is not 0. Okay, I hate to break it to you. It's undefined. Okay, undefined. So you don't trust me? Some of you are kind of like, I don't know about that, Mr. 13, making stuff up here. Try it. 12 divided by error, divide by 0, right? You just can't do it. Okay, so if you're ever not sure, just try it. It's fun. All right, so the equation, write this down at the bottom, the equation looks like this. Will be x is equal to a number. Okay? No y variable. That's how you know it's a vertical line when there is no y variable. And sometimes you're only gonna find out once you do a bunch of math and you're gonna combine like terms like, whoa, wait a minute, my y variables cancel out. Oh, it's only x left. That must be a vertical line. Okay. And the next one is the zero slope horizontal line. So if the line, if the slope is 0, right, it's a horizontal line. So you pick anywhere you want, okay? And that's what your line will look like. The equation looks like this: y is equal to a number, and there's no x variable. I want you to think of it a different way, though. Think about it. No matter what your x value is, no matter what it is, y is always going to stay this across the spectrum. Y is always staying, let's say this is -2, y is always -2 no matter what. Over here, let's say x is -2, x is always going to be -2 no matter what. Okay, so think about it that way as well. That will help you out. Okay, let's keep going. So there's your four different slopes. And now I'm going to show you how to graph linear equations by hand. So we're interested in that boundary line, okay? And so later on, we're going to shade either the area beneath it or above it, okay? You're with me? Okay. So when you have something like this, you should all agree, you should all look at this and be like, what's going on here? There's like an X there, there's an X there, a Y there, there's stuff all over the place. I want you to combine like terms. Okay, combine like terms. That's what the first thing I want you to do. So I don't know if you remember, but I just bring stuff over, right? So 5x, I'm going to bring this 2x over. Let me use a different color for the 2x coming over. When it crosses the equal sign, it turns negative. Right? When it crosses over here, and then there's the plus 2y is equal to 6. 6 remains on the other side. And there's a strategic move why I make it look like this. So 5x minus 2x is, you with me? 3x. Thank you. This is what we call, do you remember the standard form? Standard form, general form, remember those forms? Don't worry so much about the names, to be honest, but this is what we would call standard form. This is the one I like you to get to every time, if you can, at the beginning. Let's write that down, standard. Now it's in standard form. Now I'm gonna go from there. Just a brief reminder before we graph, like if you look up here, same as before, right? We label our x and a y axis. We choose an appropriate and consistent scale, arrowheads if applicable, label line with the equation, just like before. Okay. So I'm going to show you two methods of graphing because I think you should already know them, but it doesn't hurt reviewing it. So first method is finding the x and the y intercepts. So let's bring this with us. Let's take this here, 3x plus 2y. So let's say we start off with this. We moved stuff around, and now we have that. And every teacher does this differently, but I like to do the x and y intercepts side by side. So x-intercept, that's when y is equal to 0, correct? Right? Okay. And then I make a t-chart, watch. I'm kind of making a t-chart. The y-intercept is when x is equal to 0. And I do that side by side. I will zoom into that side here real quick. Okay, so later on I won't show you this, but you're basically inserting 0 right into the y slot, and that's equal to 6. So that's just really 3x is equal to 6, and then we divide by 3, and x is equal to 2. This is not an equation, guys. You just found a point. What's the point? 2, 0. Like you said that when y is equal to 0, x is equal to 2. So that's your x-intercept. We do the same thing with the y-intercept. 3, 0, 3 times 0 plus 2y is equal to 6. 3 times 0 is just 0, so you end up with 2y is equal to 6. Divide both sides by 2. Y is equal to 3. 0, 3. That's the point you just found. That's your y-intercept. Okay. And then, because you will see later on, there's going to be a bunch of these you need to make for every line that is in question. And I'm just going to say, hey, let's box this in. This goes together here. Okay, let's graph this. So we're good writing this down. Okay, so another thing I'm going to tell you is that the intercepts are great to tell you what scale to use, because down the road you might have hundreds or thousands here. So you're like, okay, in this case it's just small numbers, so easy peasy, right? So we're going to go down here. I'm going to keep those intercepts visible, and you just have to be a bit of an artist here. So 2, 0, that'd be 1, 2, right? But I'm going to go out to 5. Try to equally space it. So 1, 2, 3, 4, 5. This is my 5 mark. And 0, 3 would be right about here. No problem. I'm going to go up by 1 as well. 1, 2, 3, 4, 5. 5 positive. And because I want it to look nice, I'm going to go 5 down like this, negative 5, and then 5 backwards. 1, 2, 3, 4, 5, negative 5 there as well. So this is just a scale of 1, and 5 in each direction will do the trick here. I already labeled x and y for you because, right, like it's already there. So let's just plot these points. 2, 0 goes right here. and 0, 3 goes right there. I do not need you to write those numbers, those coordinates anymore, because you're telling me clearly up here that that's what you found. It's too much work having to redo that. Okay. So here's your line. Go nice and past those points you've plotted, because those are just 2 points on the line. That's all you need. Remember they told you 3 points? I don't know if some teachers told you 3. Technically for linear, you only need 2. Okay? They lie to us. Anyways, so that's my line. And don't forget about the equation. 3x plus 2y is equal to 6. There we go. Question. What if I had done, I'm going to go back here. Back up, back up, back up. What if I had done some combining like terms here and all of a sudden I just end up with that? Like everything cancels out as 2y's. Oh, wait a minute. It's only y left, right? This would actually be, if you divide both sides by 2, be y is equal to 3. It would actually be a horizontal line. Okay, so I'm prepping you for the scenarios. Okay, this is my second method of graphing. So we did with the intercepts. This is my second method. Both of them are acceptable. So I will rewrite into this form. This is slope-intercept. Slope-intercept form. If you need the name, there's the name. Why is it called slope-intercept? Because it has the slope and the intercept. Y is all on its own, right? So that's why the name is given. Let's do this, okay? So let's start with the same one that we had up there once we combined like terms. Our goal is to isolate y. So I'm going to keep 2y equals the 3x comes over on the other side subtracting. The 6 is already there. It just keeps its sign. And then I have to, what do you have to do next? 2y, so I have to divide everything by 2, correct? Because I want to cancel this. Y is equal to, watch how I split it. This 2 is affecting both terms, guys, not just the 3x. So it's negative 3x, sorry, negative 3 over 2x. That's just how I tend to write it. And then 6 divided by 2 is 3. One of the common mistakes is students write down 6 here. They forget to divide the constant. Okay, so don't be that student. Okay, so what do I want to say here? My B is the y-intercept. And the y-intercept is 3, positive 3. Okay. Should I use a highlighter here? Plus 3, that's how I got that. And then my slope is negative 3 over 2. This number here is this one right here with sign and all. Okay. Question. It's a negative slope, right? Which way is the line going to go? From left to right? It's going to go down. We already know that, right? Why are you asking us these questions? We already know that, but this is just to confirm that we're right. So it's going to go down. Negative slope. Therefore, it's going to go down. And it's diagonal because it has x and y both present. So we know it's the same graph, so let's just go ahead and go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then do that in every direction. Okay. So how do you graph this one? Anybody remember from grade 10 how to graph this one? Want to take a risk? Nobody? I don't want to take a risk. You start with this one. You start with the y-intercept. So y-intercept is right here. Boom. I'm going to actually use orange for that one. Okay. Start with that one. And then we use our slope to go from there. This slope is literally telling me, hey, go down 3 and then over 2. That's what the slope is telling me. So I'm going to go 1, 2, 3. And I'm going to go 1, 2. Sorry, right there. That's my next point. Okay. I'm going to go down 3 over 2, right? 3 down over 2. And so that's how I got my second point. And now we can graph this thing. We just need 2 points. Three x plus 2y is equal to 6. It's the same equation. It just looks different if you rewrite it like this. Is that blurry or what? It's my vision just going here. All right. Just so you know, either method is fine with me. You will see that down the road. I'll probably use this one a bit more, but both are fine. Okay. So let's go over to page 6. And I think it's time for you to try. Notice what I'm doing here. Go to page 6 real quick. For each of the following, I want you to determine the intercepts, so the x and y intercepts. Then I want you to rewrite it into y equals mx plus b format. All right here. It should all fit, right? And then graph using a method of your choice. So you could choose these intercepts that you found, or you can choose to use this equation. You start at the y-intercept and then you use your slope to give you the next point, okay, to go from there. So let's try to do A and B, and then I'll take it from there. Okay. A real quick. Okay. So to find the intercepts, it's already, pay close attention to this, it's already how we want it, correct? It's in standard form, which is like your x, your y, and a number on the right side. Perfect. I go x-intercept, y-intercept, break it down. For when it's x-intercept, y is equal to 0. So watch how I just take a shortcut there. This whole thing is 0, so it's really just 4x is equal to 18. When you divide both by 4, x ends up being 4.5. So the point you just found is 4.50. And for y-intercept, my x is equal to 0, so that whole term is gone. So I'm left with negative 2y is equal to 18. Divide by negative 2, very important, not just 2. And so that's negative 9. So that's 0, negative 9. Okay. This should be the fact that the y-intercept is negative 9 should be confirmed when you do this part. So you go negative 2y is equal to careful. The negative, this 4x comes over negative plus 18. Then we divide by negative 2. So this would be 4. So negative and negative is positive. I hope you remember that. 4 divided by 2 is just 2x. And then 18 positive divided by negative 2 is negative 9. So it's like, oh yeah, okay, this matches. If these don't match, you have a problem, right? Like something went wrong. So this is what I would want here. Okay, if to be honest, if I have my intercepts, that's what I use to graph. I don't use this one. It's just easier because it gives me the exact points where it goes through. Okay, so is it smart to just negative 9 is like way down here. So I'm going to go 2, 4, 6, 8, 10, right? So it's kind of like 2, 4, maybe label every other one like that. Question, can I just use one here along the x-axis? Is it acceptable to use a different scale for a different axis? The answer is yes. As long as you stick with 2 here. So this should be 2, 4, right? 6, 8. Like the same scale along the y. And I'm going to use 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's just there. And then I'm going to plot 4.5 is right there. And 0, negative 9 is right here. Because this would be 10. So my graph, watch. The slope is positive, correct? So a positive slope indicates that the line is going to be rising from left to right. So this is your line. It's okay if it's off grid a little bit. And again, do not say if you get this wrong. It's like, see, there we go. Don't worry about it. You're learning. Okay, you're learning. So this is what I want you to focus on. I'm still not 100% done here. So basically, your homework is going to be page 6 to 7, and I will give you some class time to do that yet. You need to be good at it. You need to be good at graphing lines, okay? So make sure you practice. It should be doable, and if you still have issues, come and see me. Let's go back a little bit to page 5. I know some of you are eager to just want to keep going, but I'm going to talk about special cases. Because I find that just talking about it doesn't really do the trick. So page 5, okay? We're almost there, guys. So it's basically x is equal to a number or y is equal to a number. X is equal to a number will be this. Y is equal to a number will be a horizontal line. Remember that. Maybe on your study sheet or somewhere. Okay. So we will first, this does not look at all the way we want it. So we're going to combine terms. So let's do this. So the 2x is here. The 3x is going to come over, subtracting. The negative y is anyways on the left side. This y, what happens to it when it comes over? Plus, right? Plus. You're with me? Is equal to 4. 2x minus 3x, negative x. Y, negative y plus y, what happens to those? They're basically gone. They cancel out. Right? If you had the same amount, it doesn't matter. So it's negative x here is equal to 4. You can't have that. So we divide both sides by negative 1. X is equal to 4. This is actually an equation. You're not finding the intercepts. This is an equation. Special case. Right? Vertical line. Going through 4, right? X is equal to 4, I should say. So all you need to do here is right? 1, 2, 3, 4. I'm going to go to 5. It just makes it easier for me. I'm going to do the same thing here. -5. You know what? I don't really care what scale you use for the y. I really don't, because it's not going to come into question here. So we just grab your ruler. It's x equal to 4, so 4 is right there. And just make sure it's a vertical line. Boom. This is a line x equal to 4. It's an actual line, it's not the intercept. Make sense? Of course it does. You had good teachers in grade 10. Yes? No? I don't know. So, another special case and then I'm done. I promise. Then it's all on you here. It's not the way we want it, right? Definitely not. You know what bothers me here is the half. I don't like fractions. I don't know about you, but I don't like fractions in the equation. How do you get rid of them? Just multiply. Multiply in this case by 2. The whole thing, both sides. I'm just going to go times 2. The whole equation. I don't know if you knew you could do that, but you can't. That gets rid of this, right? It just gives you y minus 4 is equal to 2y minus 10. Sorry, 2y minus 10. I will make a note here, get rid of 1/2, right? And I do that multiplying by 2. If it had a 3, 1/3, then that's what you got rid of, right? You multiply everything by 3. And now we can combine like terms. Y, the 2y comes over to the left, subtracting. And the constant, I want it over on the other side. So it's -10 plus 4. You're probably like, what just happened there, right? The 2y came over to the left, subtracting. The 4 here came over to the other side, adding. -y is equal to -6. Can't have that. Y is equal to +6, right? Negative divided by negative is 6. Oop, you can't see that, sorry. There. Special case. Horizontal line. Going through y is equal to 6. So we go 1, 2, 3, 4, 5. I'll make the 6th line, but I'll just label the 5 here. I would be okay you just doing that. I honestly would. Just go to 6 here and a nice horizontal line. Not forgetting to label it. You're good. That's the special case for you. So you work on pages 6 to 7. There probably will be a short AC on this tomorrow. Just to know, do you remember how to graph? Do you really know what you're doing? So you just do page 6 and 7. I will look for the key posted. You check right away. And then you get ready for tomorrow, okay? Thank you, guys.